In this video, we will introduce writing servers within the Java programming language. A time-of-day network service that simply sends the current local day and time as an ASCII string to any client that connects to port 5x5 via either TCP or UDP. We're going to write a robust implementation that handles TCP and UDP connections and includes exception handling and error logging. This more advanced server demonstrates server socket channel and datagram channel and shows us how the program can wait for activity on both channels simultaneously using a selector object. We will use our simple datagram-based client of the time of day service for testing. Let's walk through our code and gain understanding of writing a server through an example. First, we handle the startup exceptions at the end of this block. We get an encoder for converting strings to bytes. Here we have our port for testing with non-root accounts. This is the port we'll listen on, passing it to the iNet socket address, or our local port. Here we're going to create and bind a TCP/IP channel to listen for connections on this port. So we use the socket channel.open and then we bind the local port to that. We also create and bind a datagram channel to listen on. Here we specify non-blocking mode for both channels since our selector object will be doing the blocking for us. The selector object is what allows us to block while waiting for activity on either of the two channels. Following that, we register the channels with the selector and specify what conditions a connection ready to accept a datagram ready to read we'd like the selector to wake up for. These methods return selection key objects, which we don't need to retain in this example. This is an empty byte buffer to receive empty datagrams with. If a datagram overflows the received buffer size, the extra bytes are automatically discarded, so we don't have to worry about buffer overflow attacks here. Now we loop forever processing client connections. We handle per connection problems below. We wait for a client to connect, and here we render our time that we will be returning to the client. If we get a client has probably connected, so we put our response into the byte buffer. So our time here, we're going to wrap it in a character buffer and encode it in our byte buffer. We get the selection key objects for the channels that have activity on them. These are the keys returned by the register methods above. They are returned in a Java util set. Now we iterate through the set of keys. We get a key from the set and remove it from the set. We get the channel associated with the key. Now we test the key and the channel to find out whether something happened on the TCP or UDP channel. If a client has attempted to connect via TCP, we accept the connection now. If we accepted the connection successfully, then send our response back to the client. Here we send our response and we close the connection. A UDP datagram is waiting. Receive it now, noting the address it was sent from. If we got the datagram successfully, we send the data and time in a response packet. Here we log the error but continue running. We use our class name for the logger so that a sysadmin can figure logging out for this server independently of other programs. If anything else goes wrong, out of memory for example, then log the problem and exit. Finally, this is a startup error. There's no need to log it, just print a message and exit. This concludes our discussion of writing servers in Java.